Have you ever wondered what it would be like to travel back in time and witness historical events? Or perhaps journey to the future to see what awaits humanity? Imagine for a moment that you could. Could you resist the urge to meddle with history, or to sneak a peek at tomorrow's headlines? Time travel has always held a certain allure, hasn't it? It's a staple of science fiction and a source of endless speculation. Well, time travel might not be as far-fetched as it seems. To grasp the concept of time travel, we first need to understand what time is. Let's dive into the realm of the fourth dimension, time, a concept that is as fascinating as it is elusive. Time isn't just the ticking of a clock or the turning of a calendar page. It's a fundamental part of the fabric of our universe, woven together with the three dimensions of space we're familiar with: length, width, and height. Time, as we understand it, isn't a constant, unchanging entity. It's fluid, malleable, bending and warping under the influence of gravity. This is one of the mind-bending revelations from Albert Einstein's theory of relativity. Einstein's theory tells us that time and space are interconnected in a four-dimensional structure known as space-time. Think of space-time as a giant cosmic rubber sheet. When a massive object like a planet or star sits on this sheet, it causes it to curve, creating what we call gravity. The more massive the object, the deeper the curve and the stronger the gravity. Now here's where it gets really interesting. Gravity doesn't just affect space, it also impacts time. The deeper the curve in space-time, the slower time moves. This is known as time dilation. In fact, astronauts aboard the International Space Station, where gravity is weaker, age slightly slower than people on Earth. It's not a noticeable difference for them, but it's a fascinating glimpse into the flexibility of time. Einstein's theory, however, doesn't just stop at explaining how time can slow down. It also suggests that under extreme conditions, time can twist into loops, potentially allowing for travel to the past or future. This concept, known as a wormhole, remains largely theoretical, but it's a compelling idea that continues to fuel our fascination with time travel. So in essence, time is not a rigid, unyielding river flowing in one direction. It's more like a vast ocean, with currents that can be influenced by the gravitational pull of massive objects. So, if we can manipulate gravity, can we manipulate time? Now the question arises, can we travel through time? Theoretical physics suggests that time travel might not just be a figment of our imagination, but a plausible reality. Let's take a closer look. Enter wormholes. These are theoretical passages through space-time predicted by the theory of general relativity. If they exist and if we could travel through them, wormholes could allow for shortcuts through space and possibly time. You can think of a wormhole like a tunnel with two ends, each in separate points in space and time. Now, if we could stabilize a wormhole long enough to pass through it, we might emerge in a different time or place. But wormholes aren't our only ticket to the past or future. There's also the concept of time dilation, a real and proven aspect of Einstein's theory of relativity. Time dilation describes how time passes differently, depending on your speed and gravitational field. For example, time moves slower the closer you are to a massive object, due to gravity. Similarly, if you were to travel at near light speed, time would slow down for you relative to someone standing still. This means that if you embarked on a high-speed space journey, you could return to Earth to find that more time has passed here than for you. Effectively, you've traveled into the future. Yet, it's important to clarify that these concepts are purely theoretical at this point. We've yet to discover a wormhole, let alone figure out how to keep one open. And while time dilation has been experimentally confirmed, achieving near-light speeds is currently beyond our technological capabilities. However, these theories and hypotheses are not mere science fiction. They are based on our current understanding of the universe and its laws. They serve as a testament to the power of human curiosity and our relentless pursuit of knowledge. It seems the universe might have some loopholes that could allow for time travel. But until we can test these theories more conclusively, the possibility remains just over the horizon of our understanding. But if we could travel through time, wouldn't that lead to paradoxes? Well, indeed, the concept of time travel brings with it the potential for some mind-bending paradoxes. Let's explore two of the most well-known ones: the grandfather paradox and the bootstrap paradox. Imagine you have a time machine and you decide to travel back in time. You meet your young grandfather before he has any children. Now, what would happen if you accidentally caused his demise? If your grandfather never had children, your parent would never be born, and neither would you. But if you were never born, how could you have traveled back in time to cause your grandfather's demise? This is the grandfather paradox, a classic example of the logical problems that come with the concept of time travel. Now let's consider the bootstrap paradox, which involves objects or information that exist without having been created. Imagine you're a scientist who receives a detailed blueprint of a time machine from your future self. You use it to build the time machine, and later, you send the blueprint back to your younger self. The question is, where did the blueprint originally come from? It seems to exist in a loop, with no clear point of creation. These paradoxes might seem like insurmountable problems, but there are possible solutions. One of them is the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of an event occurs in a separate universe. In the case of the grandfather paradox, the moment you cause your grandfather's demise, you create a new universe. In this universe you were never born, but you still exist because you came from a different universe. So, while these paradoxes can be mind-boggling, they don't necessarily debunk the concept of time travel. They only force us to think more deeply about the nature of time and reality. These paradoxes and their solutions give us a lot to ponder about the nature of time and reality. Even if time travel is theoretically possible, there are still practical challenges to overcome. Let's dive into some of these hurdles, starting with the technological and energy requirements. Firstly, the technology needed for time travel is beyond anything we currently have. Some theories suggest that to create a time machine, we would need to manipulate black holes or construct something called a wormhole. But these are concepts we barely understand, let alone have the capability to control. This isn't like building a car or a spaceship, it's constructing an apparatus that can bend the fabric of space-time itself, and that's no small feat. Then there's the question of energy. According to some theories, the energy required to power a time machine would be astronomical. We're talking about the energy equivalent to that of an entire star. To put it in perspective, that's more energy than humanity has produced in its entire history. But let's say, for argument's sake, that we manage to overcome these technological and energy barriers. We're still left with the dangers that time travel might pose. Physical dangers are an obvious concern. Who knows what kind of impact time travel could have on the human body? Could it cause us to age rapidly or not at all? Could it have a detrimental effect on our physical health? These are questions that we simply don't have the answers to yet. And then there's the psychological aspect. Imagine the mental strain of hopping between different periods in time, the culture shock, the isolation of being in a time where you don't belong, surrounded by people who are not your contemporaries. It could be an overwhelming experience that could potentially lead to severe psychological distress. But here's the thing. Despite these challenges, the quest for time travel continues to inspire scientists and dreamers alike. The idea of being able to traverse time, to witness history firsthand or to glimpse the future is just too enticing. No matter how daunting the obstacles may be, the human spirit, our innate curiosity and our relentless pursuit of knowledge will keep us reaching for the stars and beyond. In conclusion, time travel remains a fascinating concept that captivates our imagination. It's an idea that stirs up a whirlwind of questions and mysteries, compelling us to explore the depths of our understanding. Let's take a moment to revisit the intriguing points we've discussed so far. We started by delving into the concept of time, a fundamental yet elusive aspect of our universe. We realized that time is not merely a measure of moments passing, but rather a complex dimension, interwoven with the fabric of our reality. Then we explored the tantalizing possibility of time travel. This concept, once the realm of science fiction, has now entered serious scientific discussions, with theories like wormholes and time dilation offering glimpses into potential pathways through time. We also unraveled the paradoxes associated with time travel, such as the infamous grandfather paradox, which presents mind-bending challenges to our understanding of causality and our perception of reality. Finally, we tackled the practical challenges of time travel. From the monumental energy requirements to the potentially catastrophic consequences, the practicality of time travel is a significant hurdle to overcome. While we may not be packing our bags for a time travel trip just yet, the journey through understanding the concept is a fascinating adventure in itself.